As we get started with some more properties of exponents, we're going to just cover some vocabulary. So if it's in exponent form, like 5 to the third power, well, 5 to the third power has an exponent, so that means it's in exponent form. Okay? These aren't very tricky. The small number that we use as a superscript, that is the exponent. And the number that we are multiplying over and over again, in this case 3 times, that's the base. Factored form, 5 to the third power, is 5 times 5 times 5. Factored form means it's all factored out, as if you were going to take and make a factor tree of the number 125. 125 in this case is the standard form. It's also the way that we write our answer. Alright, so having gone through some of the vocabulary, here are a couple of things that we want to take care of. If I have 3 squared, it means 3 times 3. 3 to the third power is 3 times 3 times 3. So this is actually 1, 2, 3, 4, 5. 3 to the fifth power. So we look at 5 to the fourth. 5 times 5 times 5 times 5. And squared means 2 more. So we actually count 1, 2, 3, 4, 5, 6. 4 to the third, 4 to the third. 4, 4, 4, 4, 4, 4, 4, 4, 4. So the base number is going to be kept as 4. If I have 1, 2, 3, 4, 5, 6, so 4 to the sixth power. 2 to the third, so 2 times 2 times 2, and 2 squared is 2 times 2, so our base number stays 2. I have 1, 2, 3, 4, 5, 5 of them, so 6 to the third, and 6 to the fourth. So I have 1, 2, 3, 4, 5, 6, 7. So 6 to the seventh. So what's the general rule? Okay, obviously you wouldn't have to go back and count all these each time. If we take a quick look and study those exponents. What am I doing with my exponents to get the final exponent? Hopefully you're seeing the pattern is this. If I have x squared times x to the third, we're going to get x to the 2 plus 3, which is x to the fifth. So if I'm multiplying with the same base, in our extra example we're saying x, the base is x, all I have to do is add the exponents. And that's exactly what our rule says. For any non-zero number a, and any integer m and n, so we're talking about our exponents here. If I'm multiplying with the same base a, I'm going to add the exponents. So if I have 3 to the fifth and 3 to the fourth, we would get 3, and 5 plus 4 is 9, so 3 to the ninth. Now, as we talk about all of our different rules here, we also want to show what happens if you have multiple bases in here. So if I have ab to the third, well, it's ab times ab times ab. Well, that's a times a times a, and b times b times b. So I have 3 of these and 3 of these. So we do the same thing. I have m, 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 and n times n times n times n. So I have m to the fourth and n to the fourth. So very quickly, hopefully you're saying that the next one would be xy, xy, xx, yy. So x squared, y squared. So if I have xy squared, I end up with x squared and y squared. mn to the fourth, I end up with m to the fourth, n to the fourth. So we quickly see that cd to the fifth is cd 5 times, 5 c's and 5 d's, so I have c to the fifth and d to the fifth. And pq to the sixth, p to the sixth, q to the sixth. So what's the general rule? Well, my general rule is that if I have x times y, and I take it to any power, let's say n, I'm going to end up with x to the nth power and y to the nth power. So in essence, we're going to distribute that to each one of these exponents. So remember, our understood exponent is 1 if there's no exponent, so we can always write that in there. So 1 times n is n, and 1 times n is n again. Now, it's very difficult to separate all these rules because when it gets confusing is when it's all together. So I want to try and show you as much as I can up front. So first thing we have is a squared, a to the third, and a to the sixth. Remember, this is a times a times 3 more a's. So right now I have a total of 5 and 6 more. So we should end up with a to the 11th. Very good. Sometimes this one's tricky just because I see 7 and I see 2, so I know that that's 9, but we have to understand there's one more right here, so we should get x to the 10th. Here, don't let that pass you again. C to the third and another c makes 4, so I should have c to the 4th and d to the 5th. I have x squared and x squared, which makes 4, and one more is 5. Z to the 5th, one more is 6, 7, 8, 5 and 8. The next thing we have is I have to remember that this has to be distributed. So I have 5 to the 4th, and I have x. Well, x is squared this time, and it's also to the 2nd power. And we're going to multiply that, so x to the 8th. Now we start to separate some of our rules. If they both have coefficients, I'm going to multiply that just like you always have. So 7 times 6 is going to be 42. In this case, negative, because it was negative 6. And my rule for my exponents is to add them. So negative 8 plus 4 is negative 4. So I then have to finish my problem out by writing negative 42 over x to the 4th. Or if I have a negative exponent, that has to move that term down. 42 is to the 1st power, so that's going to stay put. And if I have both rules, like we have in the last problem here, I have to take care of my power to a power first before I can multiply. So I'll write 2x squared over again here, just bring it down. Now I have 3 squared, which is 9, and x, 5 times 2 is 10. So 2 times 9 is 18, and I have x squared and x to the 10th. That's a complete dozen, x to the 12th. Alright, using that last example, this is going to show you how we can apply this directly to scientific notation. What I want to do is multiply your a terms. So 7 times 4 is 28. Times 10, I have 10 to the 8th times 10 to the 5th. Well, that's 10 to the 13th. Now we have to think back and think, well, doesn't this a value doesn't have to be something special? Yeah, it has to be between 1 and 10. It is too big by one place, so I'm going to add 1 here. So 2.8 times 10 to the 14th. Simplified form, write your answer in scientific notation. So same type of problem. 3 times 5, 15 times 10. So I have times 10 to the 5 plus negative 12 is negative 7. Well, this is still too big by one place, so I'll do plus 1. 1.5 times 10 to the negative 6th. So really start to move a lot of our rules and combine them. So we want to make sure that you understand each problem the way it's set up. Looks like we have a repeat of the top problem, so we don't need this one. Alright, in chemistry we can use some of this. I actually use it a lot. And factor label method is what you see presented as part of your answer. Right here. If you have Mrs. Foy, she'll teach you a lot of great things with factor label. At 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. So we're talking about the whole cubic meter, this entire thing. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. So that's a lot. About how many molecules of water does the droplet of water shown below contain? So if we have this one right here. So what we're going to do is multiply all these things down. We're trying to go from molecules of water, so it's cubic meter, and we're going to divide out our cubic meters by making a conversion with grams, and our grams conversion with molecules. So we're going to first substitute everything in, then we're going to start to multiply. Alright, and we see here that if we multiply all of our A values, we're getting at 37.6666516. So I'm going to round that off. I'm going to call it 37.67. 37.67. Now you notice I didn't have to do anything with these because they all have the same base. And I know that my rule is to add the exponents, so this becomes negative 2, and negative 2 plus 22 gives me times 10 to the 20th. Again, I notice that my A value is too big by one place, so even though we're talking about molecules of water, carrying it over, we have exactly the same rules. It's too big by one place, so I'm going to add that on. 3.767 times 10 to the 21st. Final answer. Alright, we have a couple random review problems here I'd like to walk you through. And then the last part, the do you understand, I'd like you to try that. That way we can see where you're at when you come into class. So in our first one, all we're really dealing with is 2 has a power of 1, e has a power of 1, and 3 has a power of 1. So I need 2 squared, e squared, over 3 squared. This exponent of 2 has to go to every item in here. You know, we could leave it here, but we know 2 squared is 4, so 4e squared over 9. Either way, right now I want to make sure we understand our rules more than anything else. So the next thing is I see multiplication of these two, but I also have an exponent, so I do have to take care of this first. So negative 2 to the 5th and g to the 5th. I also need 4 g to the 3rd h. I'm going to bring that first item down. Wouldn't have to do anything else with it. I notice I'm going to have h all by itself. I'm going to have g. In this case, we're multiplying g to the 3rd and g to the 5th. Remember, this is 3 of the g's, this is 5 more, so that's 8 total. Now negative 2 to the 5th power. As we multiply, we'll see negative 2 to the 5th power is negative 32 times 4. We get our final answer, negative 128 g to the 8th h. Okay, I don't see any exponents on the outside, so we can go ahead and multiply our coefficients. So we're going to get 8, and then we'll start to go through the variables. A to the 1st, and 3 more makes 4. B squared, and 2 more makes 4. C squared, and 2 more makes 4. And if I have 1/2, or 0.5, and we're going to take t and square it. Now, a lot of people really shy away from making this 1/2, but if I see this 0.5 is 1/2, this needs to be squared, and this needs to be squared. And when I say this, I mean numerator and denominator. So you don't actually need a calculator for this. So this is 1 t squared over 4, or just t squared over 4. Okay, we'll continue with a couple more here. Trying to point out our rules. So we're talking about a power to a power, which will go in more detail in the next lesson. So 3 squared is 9, 1 times 2 is 2, and 2 times 2 is 4. And here I see that we overlap some things, but I don't have any exponents outside, so I can just multiply. So e 1 and 2, f 1 and 2, so f squared, and g squared. Well done. Alright, so I do want to focus back in just on some small things here. So do you understand? So 5, 6, and 7, let's check those out. I want to make sure that we have some place we can start our discussion in class if you have questions.